Okay, guys, good to see you again. Silvate kunratanak sodani eve hang por chinhut sang hang por so jagte maro pompiak mali. Anyway, let's continue about this related rates. Okay, maybe I'm going to show 3 or 4 more examples. Once again, about your midterm. Okay, I'm not sure if I'm going to give this online or in paper. But anyway, you should be ready for both, okay? Most probably, I may also give this midterm actually in paper. And at the time, most question will be like work problems like this. I want to see how much you understand the problems, and I want to see your work. Usually, I don't ask the question that requires only 1 or 2 steps, okay? So, next question. A police cruiser approaching a right angle intersection from the north and is chasing a speeding car that has turned the corner and is now moving straight east. When the cruiser is 0.9 kilometers north of the intersection and the car is 1.2 kilometers to the east, the police determine with radar that the distance between them and the car is increasing at 30 kilometers per hour. If the cruiser is moving at 90 kilometers per hour at the instant of measurement, what is the speed of the car? Okay, and of course you can read one more time, because the first time when you read this, I'm sure that most of the students, I cannot say everybody, okay, but most of the students, including me, we don't understand much. So we have to actually, read one more time and highlight, okay? So highlight the keywords, and after that, start solving the question. So actually, what's happening here? We're talking about 2 things, right? What's the problem here? Okay. So we are talking about a police cruiser approaching a right angle intersection from the north, is chasing a speeding car that has turned the corner and is now moving straight east. Right? And immediately after reading question, what do we understand from this? Now we know that actually if I draw this, right, this one is north and this one is east, right? We're talking about here. Okay, I don't know this, but let me just draw this nicely here. So this one is intersection, and this is our car, right, moving in this direction. So that is east, and this one is north, right? And police car is location is here, somewhere here. Okay, this one is police car. Let's say this P. And what is it? Speeding car. Speeding car is somewhere here, speeding car, right? And this one is intersection, 90-degree intersection, right? And now it says that when the cruiser is 0.9 kilometers north of the intersection, so that means that now the distance is 0.9, right? And the car is 1.2 kilometers to the east. So the distance between, let's say, this O intersection and the car, it is 1.2 kilometers. The police determined with radar that the distance, right, the distance between them and the car is increasing at 30 kilometers per hour. And what is the distance? Distance is the straight path, right? We're talking about this distance. That is a distance between them. And let me just label this by S, okay? Actually, that's a distance. So here is saying that at that instance, right, this distance, respect to time, is changing at 30 kilometers per hour. So this distance is changing, right? The question is, if the cruiser is moving at 90 kilometers per hour, so that means that the police car, right? So here it is, what is it? Approaching the junction, right? Actually, this intersection. So that means that here I can write here police car, that is dP and dt, that's equal to, it is approaching this 0, right? That's why it must be minus 90 kilometers per hour. The question is, at that instant, right? What is the speed of the car? So at that instant, we have to find this thing. We have to find this dc, the car, with respect to t. I had to find this. At that instant, I didn't actually write this. You can just imagine, suppose that here we are talking about some instant, right? We have a condition here, not in general. Okay, that's the question. But first, guys, really, we have to understand the question really well. And after that, we have to introduce some variables and write down what we are going to find. And after this, you should start solving the problem. Okay, now let's continue. So first, again, as see here, at that instant, right? Actually, this P, C, and this intersection, they form a right angle triangle. So that means at any time, right? Actually, I can just write this equation. If this distance between origin and police car, let's say it is y, and the distance between origin and the police, what is it? The car, right, which is fleeing from the police car. Let's say it is x, right? Then we have this equation. Here we have x squared plus y squared is equal to s squared. And all of them are changing, right, with respect to time, because when time changes, s is changing at the rate of 30, actually not, actually we don't know the rate, but at that instant, it's changing at 30 kilometers per hour, right? Y is also changing, x is also changing. Now we are going to find this dc dt, right? So that means that if I just rewrite this one, I'm going to find actually dy. So this one is, let me just write here, dy, and this one is dx dt. We're going to find this dx dt. So now if you differentiate both sides with respect to t, so here we have 2x, and here we have dx dt, plus, and how about y squared? That is 2y dy dt. And here we have 2s and ds dt, right? ds dt. Okay. So now dy dt, I know that's ds dt, I know that, right? I just need to find dx dt. So now to do this one, first take this expression to the right-hand side and divide both sides by 2x. At the time, what we have here? Here we have dx dt. dx dt will be equal to, so this will be minus 2y over 2x, that is y over x times dy dt. And plus 2s over 2y. No. I'm checking which one. dy, right? Okay. So ds and dy divided by x. Okay. So here we have s over x, and here we have ds dt. Okay. So next one is, I need to find, what is it? The last one. Let me draw a line here and continue here. So I have to find this dx dt, right? At that instant. At that instant means that, let me just write any of them. What is it? Let's say when x is 1.2 kilometers, right? Actually, x equals this, y is equal to this. I can just write together, x is 1.2 and y is 0.9. We have to find this. So that's equal to minus, what is y? Y is 0.9 over, what is x? X is 1.2. And how about dy dt? dy dt is given here. That is minus 90. And let me just move this a little bit here for now. Minus 90 and plus, and how about s? When x equals 1.2, y is equal to 1.9, we can find s, right? At this instant, what is s? S is equal to square root of 0.9 squared plus 1.2 squared. That is 80, 104 is 225, right? That's equal to 1.5, okay? So at that instant, our s is 1.5 over, how about x? It is 1.2, and ds dt, see here it is changing at 30 kilometers per hour. It says that increasing, right? And that's why it is positive. Here we have 30. And now if you simplify this, what do we have here? Using the calculator, anyway, this 9 and 1.2, 9 times 90, it is 810 over 12 plus 15 over 12, right? And 15 times 30, that's equal to 450 over 12, which is equal to 1, 2, 6, right? 1, 2, 6 divided by 12. That's equal to 1,200 is divided by 12. It is 100 and 5. So that's equal to 105 kilometers per hour. So at that instant, then that car is, actually the speed of the car was 105 kilometers per hour. Okay, maybe it's covering this, but Okay, let's move on. Next question. Example 6. A particle P moves clockwise at a constant rate along a circle of radius 10 feet. So we are talking about the 10 feet, and the particle, it is moving, what is it, clockwise, right? The particle's initial position is at 0, 10. Initial position is here. That's the initial position, right? And on the y-axis, and its final destination is the point 10, 0. Final destination is here. On the x-axis, it is 10, 0 here. Okay. And once the particle is in motion, the tangent line at P, right, in motion, right, and the tangent line at P intersects the x-axis at a point Q, which moves over time. If it takes the particle 30 seconds, right, to travel from start to finish, how fast is the point Q moving along the x-axis when it is 20 feet from the center of the circle, How fast, right, is the point Q is moving along the x-axis when it is 20 feet from the center of the circle? As see here, Q, it is moving towards the origin, right? That means the answer will be, what is it? Negative. Okay. So now at any time t, right, this theta, how can I connect this P and Q to each other? Use purple. Okay. So as you see here, it's a tangent line, right? P. The tangent always makes an angle of 90 degrees with the line segment that passes through the point of contact and the, what is this, the center of the circle. That means that this OP and PQ, they are perpendicular to each other. That's just from the angle property of a circle, right? If you just draw any radius and draw a tangent at that point, it makes an angle of 90 degrees. Now from here, then we can find actually the relation between OP and OQ, right? So what is it? It is adjacent side over hypotenuse, because I know the adjacent side, I know the hypotenuse. Now what is that? That is cosine of theta is equal to adjacent side, that is OP, hypotenuse, that is OQ, right? Or what is OP? OP is constant, it's not changing. What is changing here? OQ. OQ is, let's say it is X, right? So from here, then we can find X in terms of theta. So what is X? X is equal to 10 over cosine of theta. And we know that 1 over cosine of theta is defined as secant of theta. In a more simple form, I can write it as 10 times secant of theta, right? So that is how X and theta are related to each other. They're related to each other by this equation, right? Because they're changing things. That's our first step. And the second step we have to know here is, do I know the rate of change of the theta? And the question is saying that if it takes the particle 30 seconds to travel from start to finish, right? From start to finish, right? Start to finish, it takes 30 seconds. What does it mean? In 30 seconds, right? In 30 seconds, it travels how much? It travels pi over, what is it? 1/4 of the circle, right? And what is the circumference of the circle is equal to 2 pi times r. R is equal to 10. And now we have to divide this by 4 because 1/4 of the circle, that's equal to, it is 20, it is 5 pi, right? 5 pi. No, actually, not the distance. I had to find the angle, right? So in 30 seconds, right, the theta, it changes how many degrees, how many radians? It is pi over 2 radian, right? So that means that if you multiply both sides by 2, that means that we have 60 seconds, and by 2, right? I'm just multiplying this by 2 times. And here we have 2 times, right? And now we can get the rate of change of this theta because it's changing at constant rate. So we will get that, then d theta with respect to time is equal to, in 1 minute, is changing pi. So that is pi radians, right, per minute, right? every minute our theta is changing 5 radian. Okay. All right. Now the third thing is, now we are going to differentiate our equation. This x is equal to 10 times secant of theta, right? Now, if you differentiate both sides with respect to t, so what we have here? What do we have here? If you differentiate this x, right, both sides with respect to t, so on the left-hand side, we have dx, dt. On the right-hand side, we have a function, right? Function of theta. Theta is a function of t. So that's equal to 10 times. And what is the derivative of second function? Second function is, it is secant of theta times tangent of theta. That's the derivative of second function. Times, now here we have d theta dt, right? So at that instant, right now we're going to find this at that instant. That means that dx dt. So we have to find this when x is 20 feet away from the center of the circle. That means that when x is 20, right? That's equal to 10 times. So when x is 20, let me just open a small window and the calculation here. Okay, we are talking about what? So when x is equal to 20, right? We know that x is equal to 10 times secant of theta, right? So when x equals 20, so secant of theta is equal to 20 over 10, that's equal to 2. So from here, then what is theta? Theta becomes, what is it? 2. It is 1 over 2. Cosine of 60 is 1 over 2. That means that secant of 60 is 2, right? So anyway, so that means that now what I know here is then secant of pi over 3 is equal to 2. Okay. So that means that when x equals 20, our this secant of theta, it will be pi over 3. So I have here secant of pi over 3 times, and here we have tangent of pi over 3 times. How about this d theta theta? We all have already found here, that's equal to pi, right? And now if you just evaluate this, 10 times pi, we have 10 pi. And secant of pi over 3, that's equal to 2. And tangent of pi over 3, what is tangent of pi over 3? Tangent of pi over 3 is, it is square root of 3 over 2 over 1 over 2, right? Sine over cosine. So that's equal to square root of 3, which is equal to 20 times square root of 3 times pi. So that is, what is it? It's feet, right? Is feet? Yes, it is feet per minute. So at that instant, point Q is moving at this rate towards the origin. Okay, guys, 20 seconds break. Let me drink some water, then we'll continue. Next question. How many questions do we have? 7, 8, 9. Okay, guys, 7, 8. After that, I'll finish. Okay, 8 examples. I think it's enough. Well, 2 more questions. 7 and 8. Water is flowing at the rate of 6 cubic meters per minute, or meter cube per minute, from a reservoir shaped like a hemispherical bowl of radius 13 meters. The volume of water in a hemispherical bowl of radius r is V, given by this, when the water is y meters deep. When y meters deep and lowercase r, how about capital R? Capital R is the radius of the bowl, right? So when the water is y meters deep, at what rate is the water level changing when the water is 8 meters deep? And what is the radius r of the water surface when the water is y meters deep? At what rate is the radius of r changing when the water is 8 meters deep? Okay. And just 1 minute, okay, and I check something. Okay. I just want to make sure that actually here this r in the formula, it must be the radius of the sphere, okay? And this y, it's height of the water. And I couldn't check this, but anyway, let's see. Solution. What is given here? The water is flowing at the rate of this from a reservoir shaped like a hemispherical bowl of radius 13 meters, right? So meters deep, okay. So that means that what's given here is dV dt is equal to 6 meter cube per minute. The first thing. And also it says that shaped like a hemisphere ball of radius r, 13. So the second thing we know here is r is equal to 13 meters. And when the water is y meters deep, and also the volume of the water is given by this formula, pi over 3 times y squared. And here we have 3 times r. What is r? It is 13 here. It is 13 minus y. Okay, the 39. Okay, that's it. Question A. The question is saying that at what rates is the water level changing when the water is 8 meters deep? So we have to find dy dt, right? Before this, let me just simplify this further. So this 3 cancel each other. So here we have 13 pi y squared minus, and here we have pi over 3 y cubed, right? So now from here, we have to differentiate both sides with respect to t, dv dt is equal to, if you differentiate the 13 pi y squared, that's equal to 26 pi. And here we have y, and here we have dy dt, right? Minus, and how about this thing? This 3 comes to the front, that is pi times y squared. And here we have dy dt. Or if you simplify this further, dy dt is a common factor, right? So here we have 26 pi, and we have y minus pi y squared and dy dt. Because in the question is asking that we have to find this dy dt. Because at what rate the water level changing when the water is 8 meters deep, right? Now, if I just rewrite this, and what we have here we have dy dt. Dy dt will be equal to, on the left hand side we have dv dt. So here we have, let me just write here dv Can I just write it like this? Here we have dv dt, right? And divided by 26 pi y, 26 pi y, 26 pi y minus pi y squared. Okay, so that's what we have. Okay, so now we have to find this dy dt when y is equal to 8 meters, right? Seeing this. So find at what rate is the water level changing when the water is 8 meters deep. So that's equal to dv dt is given, that's equal to, what is it, 6. So dv dt is 6 over, and how about y? Y is 8. So here we have 26 pi times 8 minus pi times 8 squared, right? And approximately, let me take my calculator. Okay. So here we have 6 in the denominator. So 8 times 26 and pi minus 64 pi. That's equal to how much? That's equal to 0.013. Let's say correct 3 decimal places, or maybe 4, 0.0133. Okay, dy dt, that is meter per minute. Okay, it's changing this much. It's so slow, small, right? Also, you can leave it in terms of pi to write the exact value, but correct the 4 decimal places. That is the answer. Okay, and how about part B? In part B, in part B, what is the radius r? What is the radius r of the water surface when the water is y meters deep, right? Now see here, how can I find this? What r? So when y meters deep, so if it is y, right? How about this one? This will be the radius of the sphere minus y. So now we have right angle triangle. So here we have, then by this equation I can find r. So 13 minus y squared and plus r squared, right? Is r squared, and is equal to 13 squared, or r squared is equal to 13 squared minus, if you expand this, that's equal to 13 squared minus minus is plus 26 y and minus y squared. So these two together cancel each other. Now from here we can find r. So the radius of the surface of the water will be, what is it? R is equal to square root of 26y minus y squared. Okay, so that is the radius of the surface of the water. And the last question is, at what rate the radius are changing when the water is 8 meters deep? So that means that now in the last question we have to find dr dt. To do this one, again, we have to differentiate both sides with respect to t, right? So if you differentiate this, again, it is a composite function, because here we have 26y minus y squared to the power of 1 over 2, right? So if you differentiate this, here we have 1 over 2 times 26y minus y squared to the power of 1 over 2 minus 1, that is minus 1 over 2, times, now differentiate inside the parenthesis, right? Here we have 26 minus 2y times, now we have to differentiate y with respect to t. So that is dy dt. So we have to evaluate this when y is equal to 8. When y is equal to 8, dr dt. When y is equal to 8, right, that's equal to 1 over 2 times 26 times 8 minus 8 squared to the power of 1 over 2 times 26 minus 2 times 8 and times, how about dy dt? Dy dt we have just found here, right, in the previous one, right? So I can just write the exact value, and after simplify, what is the exact value of dy dt? Dy dt is equal to, actually both numbers are divisible by 2. I can write here 3 over, and here we have 4 times 26, and 4 times 26 minus 64 is 32, right? That's equal to 72. What's 72 even is divisible by 3. So that's equal to 72, 1 over 24 pi. This thing is equal to 1 over 24 pi. Okay, it's equal to this. 1 over 24 pi. Now, if you simplify this, here we have 1 over 2, that is 1 over 24 pi. Let me just write it as 1 over 48 pi times, and 26 times 8, right? 26 times 8 minus 64, that's equal to 144. So here we have 144 to the power of minus 1 over 2 times, and 26 minus 16, that's equal to 10. So that's equal to, here we have 10 over square root of 144, that's equal to 12. 12 times 48 pi. Or if you simplify by 2, here we have 5 over, it is 6, right? And what is 6 times 48? 6 times 48 is equal to 288 pi. And it is R, right? It's changing, what is it? Meter per minute. Okay. So at that instant, it is changing at this rate. Next question. Guys, the last question. Let's also do this. I think you're also tired. I'm also tired. But we have to learn. Okay. The last question. Okay. Hopefully I'll try to finish in 10 minutes. A jet airliner is flying at a constant altitude of 3657.6 meters. Now I said constant altitude. That means that the height with respect to the, what is this? Vertical height with respect to the ground, but it's not changing. Constant altitude of 3657.6 meters above sea level as it approaches a Pacific island. The aircraft comes within the direct line of a side of a radar station located on the island. So this one is R, right? That's the radar station. And the radar indicates the initial angle, initial angle between sea level and its line of sight to the aircraft is 30 degrees. So this theta is 30 degrees. How fast in kilometers per hour is the aircraft approaching the island when first detected by the radar instrument if it is turning upward counterclockwise at the rate of 2 over 3 degrees per second in order to keep the aircraft within its direct line of sight? I didn't understand much. Let's read it one more time. Okay, the jet airliner is flying at the constant altitudes. All right, the aircraft comes and within the direct line of sight of a radar station located on the island, and the radar indicates the initial angle between sea level and its line of sight to the aircraft is 30. Okay. All right. So the first time, you know, that the airplane, right, it enters in the, what is it, detecting zone of, let's say, this radar, the angle between the site and the ground is, it is 30 degrees. How fast in kilometers per hour is the aircraft approaching the island when first detected by the radar instrument if it is turning upward, clockwise, counterclockwise at the rate of 2 over 3 degrees per second in order to keep the aircraft within its direct line of sight. Okay, let's see. If we have no idea, we have to start somewhere, right? So the first time it detects 30 degrees and this angle and also this angle, they are equal to each other, right? So we are changing that actually, this theta, right? How fast in kilometers per hour is the aircraft approaching? We have to find this approaching. Let's say this X, right? So this one is, let's say, the distance, right? At the distance. So let's say this one is O, right? And the distance between the airplane and the island, let's say this X, right? So we have to find this. and the height is given. If height is given, right, I know this height, that's equal to 5657.6, right? So that means that also this one is x. So what we know here is then angle, right, opposite side over adjacent side, it gives us tangent function. So that is tangent of theta at any instant, right? That's equal to 5657.6 over x, right? And since we are looking for x, I can rewrite this. So this x is equal to 5657.6. Actually, if you cross multiply, here we have over tangent, right? And what is 1 over tangent? 1 over tangent is cotangent. That is cotangent of theta, right? So we have to find the rate of change of this one. What I know here is, I know this thing. Here we have d theta dt, right? It is changing at 2 over 3 degrees per second at that instant. At that instant means that 1 theta is equal to 30 degrees. So now if you differentiate both sides respect to t, here we have dx dt, right? So that's a constant number, 5657.6 times. And what is the derivative cotangent function? If you remember, that's equal to minus cosecant squared of theta, right? And here we have d theta dt. Okay. So when it is 30 degrees, then I will evaluate the thing, right? Let me just write here dot dot dot. We have to find dx dt when theta is equal to 30 degrees. That's equal to 5657.6 times, let me put minus here, cosecant squared of theta, that is 30 degrees, times, right, d theta dt, and that's equal to 2 over 3. So now if we evaluate this, here we have, what is this? 2 over 3 times 5657 point, it is 6 times cosecant. Cosecant means we have cosecant in the calculator. We don't know. So I can just use the fraction. 1 over cosecant is 1 over sine, right? So 1 over sine, actually sine of 30 is 1 over 2. So that means cosecant is 2, squared is 4, right? So this must be, it is 4. So it's just equal to 4. Equal to 4. So that's equal to, that is minus 15,086 degree per second. Okay. I have to change this into, what is it? How fast in kilometers per hour, right? This one is meter per second. Not meter per second. Kilometer per second. Okay, this one is meter per second. Degree per second. This one is meter. Meter per second. Okay. So this one is meter per second, right? Because this one is given in meter. Okay. Then we can change this into kilometer per hour. Just multiply this by 60 over 1000. We will get the answer in kilometer per hour. Guys, thank you very much. That's all for today. Most probably you will have quiz next week from chapter 3. I mean, most probably means that's, hopefully if I don't get sick, if everything is okay, next Thursday you're going to have 1 hour quiz, and after that you will have midterm. Okay, midterm, I will let you know soon. Most probably you'll have midterm in paper. Thank you very much. Have a nice weekend. See you next week. And I have already finalized your what is it, quiz 2, and also I have already started putting your assignment to scores. If there's any problem after that, after today, okay, tomorrow have a look. Tomorrow, if there's any problem, you can just let me know. Okay, then we can update your score. Thank you very much. Have a nice weekend. See you next week. Thank you. Bye bye.